Hello, everybody. My name is Halo. Welcome back to this series where we're dealing with programming and design patterns in Python. In this video, we're going to be talking about a very interesting design pattern, which is decorators. Now, decorators might be one of the most interesting patterns we have in Python for the functionality that it really offers, but also at the same time it can be a really intimidating, really complicated, really overwhelming topic when the first time you're going to be dealing with this. So we're going to be taking this very slow. I'll tell you what decorators are. I'll try to make you understand using analogies. We'll slowly build up about the types of decorators that Python has. We look at one or two. We look at how that works also and the code implementation for all of that. Now, I will advise you this. The first time you watch this video, especially if you're watching it at higher speeds, you might not understand what the concept is. I'll try my best to teach it to you, but if you're not able to understand, I'll say two things. One, rewatch this video again, maybe take notes, and number two, try this out for yourself, because that is the real way how you learn a lot of this. So without any further ado, let's get into this and discuss what decorators are. Decorators are used to wrap a function to give it more functionality. At the crux of it, this is what a decorator is. To give you an example, think of a cake. Okay, so cake is very delicious, but you can't carry it everywhere because it won't have protection. You get dust, all of that. So the cake is wrapped in a box. Okay, now what is the functionality that the cake gains? Well, it gains protection, correct? So is the box a decorator? Yes. Now, this box is kept in a cover, making it easier to carry. So, making it easier to carry is the function of the cover. So, here you have the cake. On top of the cake, a box goes, and on top of the box, a cover goes, adding more functionality. Is cover a decorator? Yes. In all of these cases, the main content of the cake is still preserved, but they're adding layers on top of this, right? And if you want to eat that cake, what will you do? You'll remove the cover, then you'll remove the box, then you'll eat the cake. So you're going to be unwrapping all of these layers one by one. So how that works is, if you have a function and you have it decorated over some more functionality, this will wrap one by one before you get into the actual function. That is how the order works. Okay, so decorators always run before the main function. Okay, I hope you're up to speed with what I just talked about. If you're not understanding, you can rewind and see this part again, because this is very important for whatever we're about to do. Okay, so let's go into the code. Did you guys know, when you're defining a function, right? And let's say name, for example, I'm going to print hello, and then do name. And then what I'll do, I'll simply call this function with my name. Okay, Python 3.10 is what we need. You can see hello Vishnu comes, and that's my name. That works perfectly. Now, did you know we are passing a string here, but we can actually pass a function as a parameter to a function? Did you guys know that? Well, I'll teach you how we can do that now. Let me create another function. Now, instead of actually greeting, let's say we can register. I'm going to be registering my name in some portal. Then using that data, we're going to be greeting us. Okay. So what that will do, it'll simply say your account has been successfully registered. So instead of me giving my name here, I'm actually going to pass another function as the parameter. And what will I do here? Well, nothing. I will go ahead and print welcome, sir. And then I will return this other function back to the user. Now, if I create a variable, and in this variable, I am going to create greet, and I have to pass another function. I'm going to pass the register function. Okay. Now, if I go ahead and run this APC, what happens? You can see that welcome, sir, along with your account has been successfully registered is run. This is how decorators work. Before actually running this function, we are running some more functionality. In this case, it's just print statements, but you get the point, correct? Now, this is the very basic way about how to think about a decorator. Okay, so you have a function, you want something to run before that function. So you create another function with a parameter which takes a function in. You put your functionality, then you return the function back. So when the user is calling this, they actually call the function that you have, and that calls the function before it, and that's how you go. Okay. So let's talk about what decorators really are. I want you to imagine this case. Okay, so we have actually put here something called greet of register, right? So instead of this, I'm going to put register is equal to greet of register. Okay, then I'm going to actually run this register function. Do you guys know what will happen if I do this right now? Well, it works fine, but I've actually made one very clever thing here. Instead of me creating and assigning this to a different variable and then calling it, I am just calling the function's name now here, and that automatically calls whatever is before that. Okay, so I'm modifying the function itself to have more functionality. So instead of me having some different variable name, I can just have the same name as the function. I can have the same name as the original function. Now what register does, register greets and registers. Okay, if you're able to follow this, and now is where we will get a bit more tricky, a bit more complicated, but a bit more interesting at the same time. So this is a lot of code for me. I'm going to write this twice. I don't want to do that. How will I fix that? Let's use decorators. And how that will look like is, I will go ahead and create the reg. So this will be the same as before, right? So this will be here, right? So this will be the decorator function. Okay, and then we are going to decorate this with another function. So I will say this will be right here. This will be also the same function, but before this function runs, let me just do this. What does this do? At greet. What does that mean? Let's deal with this a bit. But before that, let me just go ahead and put what register does. And you can see that whatever I've done here, that's the same thing that happens here. That's very interesting. What really goes on when I do greet is nothing but these two lines. What that does is it will say having this greet is the function name that we have here. This will be nothing but equal to register will now be equal to greet of register, and that's it. This is the line that we're trying to replace, and the complexity that we're trying to replace by adding a decorator. I hope this is something that you can understand. If you change the function name here, welcome, I'll say hello sir also, and I just need to put the name of the function here, and I run this, you can see that it still runs. So what this at and this particular function does is it uses this function as this function of this function with the same parameter. So that function will be this function of having that function as a parameter. Okay, maybe that's a bit tricky when I say it in words, but I hope you're able to understand with all of these examples that we just took place. Okay, now that we know what decorators are, let's deal with a couple of decorators in Python. Let's start with the at property decorator. What is the add property decorator? The add property decorator is used to disguise a function as a variable. Okay, disguise a function as a variable. Why would we need to do that? Well, functions are dynamic, variables are static. That means once you assign something, that variable will not, it can change to a different value. But let's say every time I call a variable, I would want a different value or the latest value. That is something that we cannot do because functions are dynamic and it will provide the result based on parameters, but variable will just provide the result of when it was last assigned to. Plus, we can use it to access the add property decorator. We can use it to access private variables by converting into public variables. Now, I threw two curveballs at you, two very distinct topics and some hard topics as well. Let's unwrap this one by one, just like how a decorator does. Let's deal with the first topic here. What do I mean by functions are dynamic versus what variables are? So I've gone ahead and created an employee class here. Okay, let us consider this class where in my constructor, I'm taking the first name, the last name, and I'm setting a variable called email. This is an attribute specific to this class and specific to the object. That email will be nothing but first plus last name at ssn.com, which is the domain I'm choosing, for example. And I also have this function called get details. What I'll do is it'll take your first name, print it, it'll take your last name, print it, and it'll take your email and print it. Awesome. Now let me just create an object for this. I'm going to go and create, and I will create someone called, say, John Cena, right? And what I'll do is I will actually go ahead and get the details of John Cena. You can see the name is John Cena at ssn.com. That is what we declared over here. Awesome. Now what I'll do is I'll actually change the name of John Cena into James. Okay. Now I will go ahead and get these details again. You can see that the first case John Cena email is John Cena. That is awesome. But in the second case, the name, first name is changed into James. The last name still remains Cena. The email should actually be jamescena at ssn.com. But instead of that, it is John Cena at ssn.com, which is something that should not happen. This is what I was talking about with the first point. This variable, whenever we first declared it, we said first name plus last name and this, but it should actually be a dynamic thing. If I'm able to modify this first name and I call this email afterward, it should take the latest first name that I have. And this is something that we can follow with add property decorator. As we said before, add property is used to disguise a function as a variable. So when calling this, I can actually, so this will be, so when I print this emp.email, right, you can see that it prints the email here. I'm just calling a variable here. But can we disguise the same call into an actual function which goes through? Yes, we can. And that is where this comes in. I'm gonna write the same class again so that we can modify this. Okay. So what I will do is using add property. Okay. So instead of me putting my email here, I'm going to go ahead and comment that out. I'm going to create an add property decorator, and this decorator I'll define a function called email, and this email will take self. Okay, because we're taking we are using data from this particular object, from this particular class, therefore we will keep that parameter self. Okay, then what does this email function return? It does nothing. It actually does whatever we're doing here. So I'll say self dot first name plus self dot last name plus at ssn.com, something that we're using, right? And then we get the same details. So we're adding this part alone, that add property decorator. Now I'm going to use the same code that we used before, and I am going to call this. Okay, what do you think will happen? You can see first it says John Cena at ssn.com. Then it changes to James Cena once I change the first name. And now the details are James Cena at ssn.com. That means the same variable which I'm calling is actually a function disguised as the variable. And whenever I call this variable slash function, it gets the latest first name, the latest last name, and returns that value rather than returning a static value. This is where add property decorators can be used. One. Another thing, let's go with the second point here. We can use it to privately access a variable. Let me just add that as a topic here so that we can deal more with that. So let me give you some context here. Let's say we have an object which has an attribute length. Okay, and we have a class where length is a property of that, and we iterate through this class, or we get the value of the class. We do indexing based on this length property, and this length is actually a variable which can be changed from the user. If suppose that's the case, what will happen if the user sets his manual length and sets something like 10,000, and the actual object itself only has 5 or 6 elements in it as data values? What will happen if I do 10,000? That's something that will cause problems. So letting users modify this length is something that I should not do. And how do I do that in code? Well, I can just set this as with an underscore, telling that it's a private attribute. Nobody touch it. Okay. How does that look like? Well, this is what that looks like. Let me just go ahead and paste this here. This will be our second example. This is what that will look like. I have a length attribute, and this is a private attribute. Okay, so pushing to this particular element will just append this value here. I can actually, it will also increase the length. Okay, so if I actually go ahead and create an object for this object, right, and I will actually say object dot push, I'll say 1. Okay, and I'll actually print object dot length. Okay, then I'll also print this again, and I'll do object dot push of 2. Okay, and then I'll print this again. Then something that I'll do is, you can see that 0 1 2, I'm pushing to two objects. Okay, initially it's 0, after one object is pushed it becomes 1, so after two objects are pushed the length becomes 2. Now something I'm going to do is I'm going to set object dot len is equal to 200. Okay, now I print object dot len. Len, what happens now? It's just 200, but there's only two elements inside my stack, or this very basic implementation of a stack, right? That becomes a problem because we are letting the user to change this value from their end, which they're not supposed to do because this is a private variable. How do you solve that? Well, you can use add property to solve that as well. That is very simple. Instead of you using this len and sending that directly to the user, what I will do is I will create a property, and this property I will call as len of self. Now what this will do nothing but return this len. Okay, now instead of the user actually making changes to this value right here, they will actually not know that this private attribute exists at all. So instead of me doing this object dot len, I can just do len. Okay, and this will be the same thing here, same thing here, same thing here. Now what happens when I print this? You say 0 1 2 2 prints, but what happens if I try to change the value of this len property? Well, let me just go ahead and print that. So I am going to change object dot len is equal to 200. What happens? An error is thrown because we can't set this attribute len. So when you're returning these private attributes, rather than you calling these values directly, you can create an add property decorator to take these values and then return the private values. This is a much safer way of getting this problem sorted. Now let us go ahead and deal with something else now. So I can actually will throw an error. Okay, so that we can get that sorted. Okay, now that we've done with that, let us actually go ahead and deal with these concepts: getter, setters, and deleters. These are also some decorators we have in Python. In fact, what we've done here is actually a property where we're basically using the getter. Okay, and that is where getter works. Actually, getter, setter, deleter. So now that we throw this error where it says we can't set this attribute to len, which is actually a function disguised as a variable, we can actually do that. We have to add another function which is called as a setter. Okay, so how all of this looks like? So I have a class called employee which has employee's first name and employee's last name. Okay, now similar to how we created this email property here, I'm going to go ahead and create the same property here so that we can create this dynamic thing over here. Now can we create some setters and getters? Okay, so let me go ahead and create an object for this value. Okay, and that will be employee of first comma last. Okay, now if I go ahead and I want to change the first name and last name for this employee, what will I do? Well, let me just go ahead and change the put the get details function as well, because I can show you how this will be when you print this object. So I can do object dot get details. Okay, you can see the first name, last name, all of that is printed. Now if I want to change the first name, what I'll do object dot first name. I'll change this to new name. Right, I change this again, then I will do the get details. Details. I'd have to get the new name and the new last name. Now similarly, I'm going to change the last name also. So I'll change this to the last name, and this will be new to name, for example. You can see that the first name and the last name changes, but I have to write two different lines for this. Well, what if I want to give something like last name, and then I want the code to automatically detect what the first name is, what the last name is, and then set based on that? Well, that's something that you can actually do, and that is where setters come into place. Okay, so now I'm going to create another function disguised as the property. So that will be property. Okay, and that property will be called full name. So what full name does is it returns self dot first name added with the space, and then it returns self dot last name. Okay, so I will go ahead and print object dot full name. Okay, it prints the first and last name. Now what happens if I do object dot full name of new name? it will throw me an error because we can't set this attribute. In order to solve that, we actually include something called a setter. How that will work is you have to do the properties name dot settr setter. Okay, and under that you'll actually define the same class, but now we can add attributes. So there'll be self comma name. In our case, what we will do is this name will be the full name of that person. Okay, so we can take first and last name. That will be nothing but name dot split, right? And then we can set the self dot first name to be first, and then similarly we can set the set last name to be last. Now that I'm able to run this, I'm going to run the same function again. You can see now no error comes. Now if I go ahead and print the object dot full name, you can see that it gets changed to my new name. That is what a setter does. We can not only get stuff, we can also set stuff by doing this. It will automatically say what the first name is, what the last name is, and take it from there. In fact, I can prove that to you to say what the first name would be. So it can say that the name is new and not first as it was before. And I can actually go ahead and print this object dot email. You can see that the email is new name at ssn.com. So what happens is when it's setting this, automatically the first name and last name changes, and when calling this email, it takes the latest first name and last name. So all of that goes hand in hand. That is how a setter works. Okay, now we dealt with what getters are. These are getters. We dealt with what setters are. What are deleters? That's a very interesting thing. Again, let's say I want to get rid of this first name and last names, reset the value to the user. And that's where I'll actually use a deleter. And that will work as DELETER. Maybe I spelled this wrong over here. I'm sorry. It's supposed to be deleter. Yeah. Now, how that works is very simple. You have to put full name, same thing again. And this will be self, because we might use things from the class. We are going to set the self first name to nil. Okay, and we're going to set the self last name to nil. That's it. This is what a deleter does. Now if you want to use this deleter, how will we use that? We'll simply use the del keyword and then put our object dot full name. Okay, that means delete my full name, and that means delete my first name and last name as well. Now once I do this, if I actually go ahead and print the same things as before, you can see that initially the first name, last name, this comes. This also something to be understood. But in the third case, once I delete this, it resets both my first name and my last name to nil and nil, which I've done here. So my full name or my first name now becomes nil, and my email becomes my full name at that ssn.com. That becomes 2 of these underscores. That is how a deleter works. So in conclusion, in this video, we talked about a lot of stuff, a lot of things to unpack. We started with what a decorator is. Then we talked about the at property decorator, how to use that and the cases, how that is being used. Then we talked about what getters, setters, and deleters are. Those are decorators also. As we discussed, you can create your own decorator also in Python, as we did here. We started with that, in fact. Then only we dealt with what the decorators, some of the decorators that Python has. I hope this video was useful for you. This is a huge document, but this is something that you can read through and try to understand. This code in its entirety will be there in the GitHub repo, link in the description. I hope this video helped you and provided you a bit of understanding about what decorators are. If it did help you, hit that like button. It'll help me out a lot. If you guys have any questions about decorators, you can leave that in the comments so that somebody else can answer, or I can answer them when I do have the time. Thank you so much for watching. I'll see you in another video. Until then,